let's talk about the blocks and the workflows that you can have in Rhino and Grasshopper with said blocks. So first of all, if you know what a block is and how it works, just skip ahead like a minute or so, because I'm going to blab a little bit before we begin. So block is basically an instance of geometry that doesn't have a cost of being copied. Meaning if you have a certain type of geometry, let's say a box, and you need 100 of the same box in your 3D file, then you would use a block. You would make that box into a block and you would copy the block rather than the box itself. And that is just simply how it's coded in, right? Rhino understands that the geometry is the same inside of the block, so it doesn't need to reread the geometry every time a copy is made. It just says, oh, okay, so it's the same geometry, it's just its position is different in the world, right? So it just kind of making copies becomes very easy. So what can you do with a block? You can rotate it, you can move it, and you can scale it. And that's about it. That's all you can do, right? So moving, rotating, scaling, meaning translation stuff. But when it comes down to morphing and twisting and so on, nope, that ain't gonna happen. So there are benefits and trade-offs. Usually in the architecture industry, blocks are used extensively because there are so many repeating parts like bolts, nuts, screws, beams. I think I will show you the tutorial with beams. So that's gonna be one of the examples. Their blocks are also used in like multiple other industries, but since I'm an architect, I will be showcasing it through the perspective of an architect. So, okay, enough about that. Blocks are useful when you want to make your file very fast with a lot of repeated geometries. All right, let's jump right into it. So we are going to be creating a block definition, first of all, of an I-beam, a metal beam that's quite used in architectural industry or engineering, I should say. So in the top view, first we need to draw out our kind of cross section of the I-beam, and I'll just first create a rectangle. This is, you just draw a polyline, so you can draw it any way you want. This is the way I do it. I just draw a rectangle and I decide on what's the size of my I-beam, and let's say I'll go for 200 millimeters wide, 250 millimeters high. Zoom selected, ZS. This is the outer bounding box of my I-beam. And now inside of here, I can kind of draw, let's say, this C shape, like that. So this is like one side. I can offset, and choose what's the thickness of the offset. And also while I'm doing this, I think there should be, yes, there is this cap option here. So instead of cap none, I choose cap flat. Distance 1 centimeter, sure, that's fine. And we have ourselves a pretty thick C profile. So an I-beam is basically two C profiles that are slapped together. So I can just mirror it like that. And here's my I-beam. Technically, this middle section can be thinned out a little bit. So I can move in these by 5 millimeters. These 2 points and these 2 points. Oops. Like that. And now I know for a fact that this is going to be like 1 centimeter uniformly in all, on all sides, I guess. Then I select both of these. I create planar surface from both of these. At that point, I can just delete the curve. I don't need it anymore. I select the two surfaces, I join them up, and I type in merge all coplanar faces to basically clean it up and get a single surface out of these two. So back in perspective view, I can see the cross section right here. Now I want to position the cross section to be, to be cleanly placed, I guess. So I want it to be centered, right? So I'm just going to move it, since this is 200 wide, I'm going to move it back by 100, because the origin point really matters in the blocks. I should mention this. Minus 100. So now 0, 0, 0 is placed right here. And then I will take this Y arrow and move it back by minus 125, because the whole length is 250 millimeters divided by 2, 125. So now my beam is centered, right? And you can see that its length, or not its length, its height will go along the Y direction, its width will go along the X direction. This will be important later. So with the beam selected now, I can simply click on the gumball extrusion button right here, the little dot, and type in 1000 millimeters. I need to remember what's the default height of the beam, or not height, length of the beam, and that is going to be a length of 1000 millimeters. If I just look at it with a shaded view, this is how it looks like. Nothing special, just a beam, right? Now, when I have this geometry, I need to convert it into a block, right? So I can select it. I can type in block. It asks me for where is the block base point, and the base point, the reason why we moved it to be centered around 0, 0, 0, except for the length doesn't need to be centered, only the cross section. So centered around 0, 0, 0 is because it's gonna be easier for me to define the base point now. I just type in 0, hit enter, and it basically uses the world's 0, 0, 0 as the base point of the block, and then give it a name. Beam, hit OK, and that's it. Now we have a block. So every time, basically at this point I can delete it, by the way. I don't need it. If I type in block manager, you can see that my beam block definition lives here in this particular file, in this particular block manager. If I want to get it into the 3D model manually, I would need to type in insert, and here, according to the name, beam, I can insert it with a specific, I don't know what's the word, but like specific translation, I guess, for the block. I can just hit OK, and wherever I click, there's a beam. So now if I were to just copy these, and copy these by quite a bit, this will not bog down the computer as what would happen if I had a poly surface and was copying it, right? So these are super lightweight now, because it only has one definition to deal with, one type of geometry to deal with. Okay, now we're starting to go somewhere, right? How do we use these beams in some sort of a setting? So let's say I have, I have a gable roof, right? And I need to place the beams. Well, what's the easiest way of how to align these beams? If I were to just draw, let's just draw a single line that is like 5,000 millimeters, 5 meters long. Let's just make a copy of it and draw and play around with the control points of it to make it all crooked and so on and all weird. Like that. 2 lines, right? One kind of line like so, the other one like so. I will want to a Grasshopper definition. So if you don't have Grasshopper opened, open it up now. I will want my Grasshopper definition to automatically place my beams along these curves. How do I do that? Well, I first need to reference in the curve component. Don't worry about this. Curve component, right click, set multiple, and select my 2 curves right here. We have them, right? Then, after the curve component has been enabled, or contains those references for those two beams, I will need to use block insert, or whatever it's called. 1 second. Place block. I will need to use place block component. So at this point you might be thinking, wait, I don't have a place block component, and you're goddamn right you don't. It's if I hold Control Alt click, you can see that it's located in a plugin that's called Human. Human plugin enables you to do many things with your Grasshopper, with your Rhino file that, deals with blocks and also text and textures and so on. It's a very useful plugin, by the way, so you should download it. It's on foodforrhino.com, it's free, blah blah blah, you know the drill. So just go to foodforrhino.com. For those of you who are new to the channel, you register there. They don't send you any spam whatsoever. I had an account with them for like past 10 years and I haven't received a single email from them. So foodforrhino.com, find Human plugin, install it. You'll get this little thing right here. The block definition basically requires you to give it 4 inputs. First one is the name of the block. The name of the block is the block name. If I go into block manager again and I look at my name here, it's beam, right? That's how we named our block. So here I would just type in // double click, of course, / beam, like that, and connect it like so to your name, right? So then it asks me, so it's going to be ready to place the block. It asks me for what's the transform, where do you want me to place it? And the transform comes from, let's say we do rotation. The X output is the transform. Let's say we do move. Well, the X output is transform. Let's say we do orient. The X is transform. So you can use these as your as an input to the X form. The easiest one is, let's see. Oh, I will not show you the easiest one. I will show you the proper one. Let's learn properly. So for now, we don't have a transform because I will need to define some sort of a plane for the beams to be placed on. And then there's bake and attributes. We will not deal with object attributes at this point, but we will deal with bake. So bake is literally a button. A button connects right here, and every time you will press it, it's going to bake out your blocks into Rhino. So now transform, the tricky part. That's where the curves come in, right? So I'm going to say, give me the endpoint, the plane, a perpendicular plane on the endpoint of each curve. Perpendicular plane. I probably wrote it wrong. Perp. There we go. Perp frame. Not plane, frame. Perp frame. Like that. Asks me for a curve and its parameter. Usually the parameters are between 0 and 1, especially if you have this input right click here and reparameterize. If you have curve input reparameterize, then it's definitely the start point of the curve will be 0, the midpoint will be 0.5, and the endpoint will be 1, right? So I'll just connect curve here, and we need the start point, so I'll just type in //0, enter, and connect that little panel right there. I'm using panels in places where I know I will not be changing the value, right? So we get these 2 planes here that you can see are 90 degrees to the curve, right? They're perfectly aligned with the curve, and that's important because that is where, we have the world XY, and that's where the beam will be reoriented from. The block will be reoriented from. So we need this to be 90 degrees. Just to kind of explain it better, if I here change this to 0.5, you can see that the planes are right in the middle of my curve. right? So between 0 and 1. So here I'm back to 0. So we have our frames. Now what? Well, now I will use Orient command, Orient, and I don't care about geometry. I don't need the geometry. I only need the translation, and translation does or transform, and the transform doesn't require you to have geometry to orient. It just requires you to give it a source plane, which is by default world XY, and that's what we want. And because that's where we placed our beam, remember, and our B, the target, are these two bad boys right here that are really waiting for the beam to come. So I just connect it like so. Right? So we get two transforms that are called orientation transforms, and I can just connect them to X form, like that. And see, now place block is not complaining anymore, it's happy. And if I press the bake button, I can see that my two beams that are mirror long have been placed onto these two curves. Yay, we're almost there. Okay, in all seriousness, while they are placed correctly, well, unless you want them to be rotated 90 degrees, then you would need to actually rotate plane, rotate not object in a plane, or rather, is there like rotate plane? Yeah, there we go, rotate plane. You would need to rotate the perpendicular frames. Let's delete these two. Rotate perpendicular planes by 90 degrees. And the way you do is, this is waiting for radians. We don't deal with radians. We're not a bunch of nerds who don't use degrees. We will be using degrees. So we right click and choose degrees here. And we specify 90. Like that. And we connect P to B. So now we don't use the original perpendicular frame, we use the rotated version of it. Then I press bake, and we have it now rotated properly. If you want to go fancy, you can go for like 53 degrees, right? They're going to be rotated in a weird way. Let's not. Could we not? Let's not. So I will lock the angle down to 90, like that, just to make it clean. Alright, so we have that. We still do have a problem here, and the problem is called my beams are too small, too short. We need to scale them. The problem is if we scale the whole damn beam, well, that ain't gonna do it, right? Because it's just gonna, the longer the curve, the bigger the beam, all of the dimensions will scale. So the transform that we're looking for is gonna be called scale NU, scale non-uniform stretch, basically. Scale non-uniform. Again, we don't really need the geometry for this to work. We only need to scale it along the z-axis, right? By how much though? Well, this is where we take the curves that we have drawn and we measure their length. We measure their length. And I'll just show you, you don't need to do this, but just to show you, one is 5,000, this one, and the other one is, since we kind of move the control point around, it's 5,468, blah, 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 right? Two different lengths. So how do we know, by how much do we need to scale the beams to fit perfectly with the curves that we have drawn here? Well, that is going to be, since our, let me do this, insert right here, beam 0, since the block that we have defined is 1,000 millimeters from this point to this point along the z-axis, right? It's 1,000 millimeters. That means the scaling factor is going to be the length of the curve divided by 1,000, and then you know how much do you need to scale a beam to actually fit. So we just take the length, we divide it by 1,000. Now this becomes our scaling factor. We connect that to the z, and now we have two transformations to deal with. First one here, scaled 1D, and second one here. Well, now it's a little bit of a problem, because if I do it this way and I bake, you can see that it bakes out 2 beams here, and I was holding the shift key to connect 2 things into one. And also it bakes out the non-scaled versions of those beams here. So the transforms didn't add up when I was doing this. So how do you make them add up? Well, you need to use a command, or not command, a tool that's called compound. Well, I thought it's gonna be called compound transform. It's not, so now this is awkward. But basically compound. And let me try out one thing. So compound basically just takes 2 transforms and connects them into one. Let me try out one thing. I will try to connect them in a wrong order to see if it's actually going to self-correct or not. I've never tried this, because I always do it perfect the first time. Yes, it does go wrong. The thing that I did here, why it broke, was because I first connected the orient, right? So the beam or the block gets oriented onto here, and then they get scaled up in that direction, so they get stretched, and it just becomes a mess. No. First thing that needs to happen, let's disconnect. First thing that needs to happen, and just for clarity purposes, let's use merge rather than using the shift key. First, it needs to scale up to stretch out like that, and only then does it get oriented into the correct position. Then if I press bake, well, ain't this awkward? Oh, I'm being stupid. I'm sorry, I'm being stupid. Undo. Go back to me. Come back to me. Okay. So we're dealing with 2 curves, not one, right? Meaning that 2 things come in from here, 2 scales, and 2 orientations come in from here, right? And they get merged into one list here. So suddenly here, after merge, we have 4 transforms, and compound can only deal with 2, right? So what compound spits out is, well, it can deal with 4, but it deals with all 4 of them at the same time. So you end up having a thing that gets scaled up once by 5 times. I'm now reading the list here of the transforms. It gets scaled up first 5 times, then it gets scaled up again 5 times, then gets oriented once, and then that orientation gets reoriented again. So same beam gets transformed and transformed and transformed. No, that's a bad JoJo. So what we do instead is we need to separate out these scales into separate, as well as orients, into separate data branches. So we need to right click on the X and choose to graft. And we need to right click on the X here and choose to graft. What this initially does is it places the outputs into their own little branch, so they're not in the same list anymore. When they get merged, first scale gets merged with the first orientation, second scale gets merged with the second orientation, and then compound spits out 2 compound transformations for the first beam and for the second beam. So it's not convoluted anymore. They are separated out into, you know, their own, like each beam gets its own transforms rather than 4 transforms all at the same time. Right, sorry about that. That was awkward. Anyway, we press bake and now we have it. Now it's working, right? So now it doesn't matter what kind of curve you draw. Well, it needs to be a straight line, right? But it doesn't matter how it's drawn. Let Let me just really quickly show you an example. Between curves from here to here, and let's say 50. Well, not 50, like 25. All of these. Set multiple. That one for some reason is upside down. That is actually fine. No, it's not. Why? Why? Why is this upside down? I don't know. Doesn't matter. We end up having something like this. Let me show you with an Arctic view. And each of these beams are the same, exactly the same block instance, right? And they're placed exactly the same way. So they don't cost anything to place. So you can have thousands of these and they will still be fine. Your graphics card though might complain, but besides that, they should be fine. And this is where I will stop this particular tutorial and I will create another video showcasing, one second. I have this prepared. I'll create another video. In the next video, click on it. If you want to learn how you can actually use this technique to create something like this, right? And let's zoom into, for instance, this area, right? So you have metal beams, you have plates that are also block instances. We have these multi-pipe tools that connect to the plates and that are holding the beams. And all of that is used to, not tile, but to create a structure for this whole building thing, skin envelope. So if you're curious to see how this is done, check out the next video that I'm going to be doing. I'll see you there. Bye.